I just want to do a quick overview of the CPA 200 reactor. This reactor sits in the temperature control bath. So this is the heart of the system. So I just want to do a quick sort of overview on this. So two main parts. We have a reactor and we have a lid. In the lid we have 4 inlets, 1, 2, 3, 4, or 4 ports if you want to call that. In this particular one we're using one of the ports with a pressure gauge on it. One of the other ports has a bursting valve. One of the ports has a sort of a valve so you can sort of let in, let's say, gases, for example. And the other port is just blocked off. So, as I say, this is the heart of the system. This is the glass version, so this can go up to about 20 bar. If you want to go up to 100 bar, there's a tantalum version, there's a halide version, there's a stainless steel version. So, as I say, there's two main parts to this. We have a lid with 4 ports on it, and you can really kind of configure what you actually have going on in those ports. And then we have the reactor itself. So what I'll do is, I'll just explain what the 1, 2, 3 connectors here are. So in a bit we're going to have a look inside the reactor, and when we have a look inside the reactor we're going to first of all see that there's a temperature probe in there, and we're also going to see that this one's is fitted with a validation heater. You absolutely do not need to calibrate this calorimeter ever, but some people like to have a calibration heater because they once a year like to kind of put in a known power and see that the calorimeter responds in an appropriate fashion. So I mentioned that because I was saying there's 1, 2, 3 connectors on here. One of them is for the internal temperature probe, which we'll be able to see in a bit when we open the lid up. One of them is for the validation heater. This one has one, it's really not necessary. And the third one is for a Peltier heater and transducer that's in the base. So this calorimeter has a unique way of working. We call it true heat flow, and I'll sort of definitely can discuss that with you. But in order for that true heat flow to work, there's a Peltier in there, and there's a transducer in here, and there's a network of temperature sensors, and so that's what the third electrical connection is for. So, as I say, that we have the lid and we have the reactor. I just have these screws just finger tight, so I'll unscrew those and we'll take a look inside the reactor itself. And as I do that, I might just mention 2 black handles that I haven't mentioned on the lid. So if we just have a look at the lid, I have 2 black handles here. These are for lifting the reactor in and out. And people really like this reactor because it's actually quite easy to lift away from the rest of the instrument with these handles, which actually then come off so that they're not sort of getting in the way of other devices that you might want to be using. But they can lift the reactor out really nicely with these removable handles, and then really clean the reactor out quite quickly. So what I'll do is, I was just kind of wanted to touch on that. Now I am going to take the lid off so that we can have a look inside the reactor itself. What's really nice about this reactor is you only need enough volume to just cover the reactor temperature probe, which is about 10 milliliters of solvent. So you can actually run this calorimeter with just something like 10 milliliters of solvent. So we have a 250 mil volume in here. The minimum that you need to work this reactor is about 10 mils. You'll notice there's actually a couple of ports here. These ports are designed to allow you to introduce material or take material from right at the bottom of the reactor. So you have the lid with ports on it, but you also have an additional 2 ports down the bottom here. So you can see you can have something like up to 6 ports in this particular reactor. So when we look inside the reactor, we have the longer pole shaft rod is actually the validation heater, which you really don't need. It's just maybe used once a year by some customers who really want to validate that the factory calibration, which only needs to happen once, is done. And then the shorter one is the reactor temperature itself. Then if we take a look at the lid, what we have on this particular one is a propeller. We have a whole range of obviously anchor stirrers and impellers and propellers. And also we have direct drive stirrers, we have magnetically coupled stirrers, and we also have torque transducers, so you can truly know the power coming from the stirrer. So I'll put that back on and sort of summarize what we've said then. So we've said here's a 250 mil reactor, minimum working volume about 10 mils, has 4 ports on the top, 2 ports on the bottom. The 3 electrical connections are for a validation heater, which you really don't need, the internal reaction temperature, and then there's a special transducer in the base of this calorimeter where there's a Peltier and a whole series of temperature probes. Just to say that the glass or the vessel is double walled, so we have a glass wall, an air gap, and another glass wall. So great. So if you have any questions, don't fail to contact us at chemisense@cirrus.com. Thank you very much.